Hi, everyone. Thanks for joining us today. And you may have heard that we did a previous webinar on this topic. So this is sort of a reprise. However, you're privileged to be on this now because we have more information that's come out since our last webinar. And also, Dave Herron is going to provide us with his own unique perspective on what happened. This is a unique opportunity, let me put it this way. Systems go bad, we know that, but never so publicly. And unfortunately, it was an embarrassment for many and a problem for the country as a whole, but it offers lessons learned, which we rarely can gather from a failure like this. And so let's make lemonade out of lemons here and see what we can learn. I'm going to move to the first slide in the presentation. I want to give you a feeling for HealthCare.gov, what it's made of. For those of you who haven't been obsessing about it like we have, you may benefit from a little introduction. So this organizational diagram gives you a sense of its scope. 55 contractors, 5 federal agencies, stakeholders beyond that, over 300 insurance providers, 4,500 health plans. You get a feeling for how large this is. Some of the major players, of course, CMS, the federal agency, but also some major private entities, CGI, Equifax, USSI, people who know what they're doing, people who've done these sorts of things before. So we're not dealing with just anyone on this project. And then a range of the technologies that were used, many of them very familiar to you, no doubt, JBoss, Java, et cetera, jQuery, mainstream technologies, proven over years of use on high-performance websites. This is a notional diagram of the architecture in terms of the stakeholders involved. We have multiple services, so what you know of as HealthCare.gov really is a complex system that goes beyond the web interface, but nonetheless was all part of the Federal Insurance Exchange, as it was formerly known, versus the state insurance exchanges, which are a different story. You could see all the stakeholders, again, involved, from the employer or consumer to the secretaries of the agencies, various federal agencies, providing information and receiving information. And in the center core, in that light blue, a whole bunch of different features that were required to be enabled as part of the insurance exchange. A technology stack shows basically a 4-layer deep stack, or 5 really, with the data warehouse at the bottom, along with the data zone, which was the exchange that was powering everything and also interfacing with the state exchanges. And then above that, we have all the infrastructure necessary to support a high-capacity website and the connectivity into data sources that requires. We put out an infographic pretty soon after the October launch of HealthCare.gov and provided our best initial estimates based upon information we got by perusing GAO reports as an indication of how obsessive we got. We came up with $150 million. However, there was some excellent and ongoing work done at the Washington Post, and their best estimate, which was substantiated very well, was that as of launch, HealthCare.gov cost $300 million. That's not the full funding. Currently, I think the price is north of about $600 million, but as of the launch, that was $300 million. Plugging this into our model, and you see the yellow banners are updates, we came up with, for that money, you can buy about 2.7 million hours. Take about 3 years. It would take you 3 years to spend all that money on a software project. And at release, you'd come up with 4,900 defects. You don't think 4,900 defects is necessarily a can't release number. They may be latent defects that don't have mission critical effects. You're going to deliver with thousands on a very large system unless you spend a heck of a lot of time getting rid of them. But you don't have that much time when you give yourself 36 months. The SEER estimate underlying this is shown, the various items here. So what does it buy you? HealthCare.gov obviously is what it buys you, or a certain percentage of it. But if you took this money and spent it on something else, you would get all of Android. You get about 20% of QuickBooks. For those of you who do accounting, you can buy 20% of that package with HealthCare.gov. And Facebook posts this. You can buy just a small fraction of Facebook with that money. So kudos to the guys in Silicon Valley. They spent a lot of money, but they gave you a lot of value. Later is, of course, better. So as I mentioned in the last slide, defects do go down. And you have the option, obviously, of pushing your project out. And this is a theme that will come up later in this presentation. You have an option of pushing your project out and reducing defects. You can release relatively early. You see that green bar starting in month 27 or so, but you're going to bear the wrath of your stakeholders if you do. What went wrong? Well, everyone started producing infographics about this, as you can see, describing all the things that they were doing to write the project and all the things that went wrong. But the best infographic probably comes from the leader of North Korea, who was glad he shut down his internet and didn't have to deal with the same problems we had. Let's go through the problems. First of all, these guys were not the developers. And because they weren't the developers, they talked amongst themselves, and they came up with things that HealthCare.gov had to do. And then they met the next month and came up with other things that HealthCare.gov had to do. And they did that ad infinitum, and that's called requirements volatility, when your stakeholders are not completely involved, among them being the developers. So things were thrown down from on high, which made problems. And also, the guys in this room, they weren't in complete control of the situation either, to be fair. In the end, more states decided not to develop their own systems, and at a state level, things are complex. When the federal government has to step in and handle an entire state system along with many others, it gets out of hand quickly. The Supreme Court stepped in with the question of whether the Affordable Care Act was legal or not. That put things on hold for a little bit. And then later on, the government made a decision requiring consumers to register before they could browse, which threw a huge monkey wrench into the entire system. The original system assumed a latency, and then they suddenly turned that around and changed things quite a bit. Because if you have to make people register right away, you suddenly have to connect to systems that aren't necessarily intended to do that validation right away. So that's a huge architectural change that was brought down from on high. Another issue with the entire system, and these are themes that are interwoven, is complexity. The state systems were complex. The federal systems were complex. Here is a wonderful diagram prepared by a House subcommittee or the Republican National Committee, one or the other, on all the little things that had to get connected. And you know that as you connect things, the number of interconnections grow exponentially. So this is a great indication of what the developers were dealing with. These are not simple systems. Anyone who looked at that website and thought, oh, it's just a website, oh my gosh, were they mistaken. This is a slide giving an example or providing a view of all the stakeholders involved. Again, showing you just how many different things had to be done at once. Integration. When I talk about stakeholders, some of them are from on high, they're political stakeholders. Some of them are consumers or employers, or they're the users using the system. But many of these are actually other systems. So this level of integration between the systems was tremendous. I'll give you an example of this. For weeks, programmers fought a problem that initially blocked and later snagged naturalized citizens who needed verification in the Department of Homeland Security. This is a 36-month system, and several weeks were spent by a team trying to figure out how to interact with the Department of Homeland Security multiply this by the number of systems involved and the delays on interfacing with other major systems, and you can see what's going to happen. These systems that they were interfacing with, many of them were legacy systems, stovepipe systems made for batch operations. The government sends you a check, they do that in batch. They don't necessarily support that online. They increasingly do, but a lot of the old systems are in COBOL and are run as jobs, and suddenly they're being asked to integrate with those systems in real time. And in some instances, they clearly couldn't, and they'd had to replicate various forms of data to make it readily accessible. But each of these things takes a lot of time. And of course, the 36 months. As you know, or as any of you who've been involved in a project knows, when you have a forced deadline, you have a problem, because you're going to go late on a project. It's almost a rule, unless you start throwing things overboard. There was a conversation between, I believe it was Anup Gupta at CNN and Kathleen Sebelius about why they stuck with October. And the quote was, "We move forward because millions of people have been waiting for health care insurance." I believe the interpretation of that quote would have been, we would have had egg on our face had we moved the date, and thus it was not moved. If you look at the actual work that was been done, this is a CMS diagram, and if the bars at the top, initiation, requirements analysis, development, test, implementation, if those proportions are correct, you can see part of the problem. These were intended to be iterative phases, kind of a unified process like iterative phase, but development and test has a much smaller proportion of the whole than requirements analysis and design. That is a problem. No software project has proportions like that. The one argument could have been made, and probably that's beyond this diagram, is that because this was such a regulatory and integration-heavy project, requirements analysis and design were an outsized portion of the project, because you needed to do so much legwork before you handed developers their instructions. However, the proportions here are so different than they ought to be on a project. It gives you an example of how much initial design was required, and potentially very out of whack proportions, which would have certainly spelled big trouble on the project. Another thing that we're learning on this is that the processes involved were pretty good on paper. They specified release planning meetings a month prior to the start of the release. They had monthly sprints, which is about right. They had a quarterly release with alpha and beta testing, internal validation, external and partner validation. Wonderful, wonderful plans. And these are actual pictures from the documents. Unfortunately, plans are only that. And so just because you're CMMI 5 certified doesn't mean the project's going to come out correctly. And this is not necessarily due to the people making the plans or the people who get certified, but reality will overcome a plan. So we've gone through all the things that went wrong. So we're not enough of that. We have to learn from this. Lessons yet again learned. Yet again, because you're not going to see that much new. But you're going to see it specifically as it applies to this. Maintain strong and enabled leadership. There was a conference many years ago now at NASA where a lot of people talked about, it was a project management conference about projects. And the one thing that came up in a study that was done of hundreds of NASA projects, the one common factor was they had strong and enabled leaders on those projects. On HealthCare.gov, on the Federal Exchange, no prime contractor was chosen to lead. None. Instead, officials at HHS, Health and Human Services, who had never managed a project this large. They don't do projects this large. Were put in charge, but even their lines of authority were not clear. So there was no dictator on this project, benevolent dictator. The corollary to that is that the biggest executive, you need to have a sponsor. Along with the leader needs to have a sponsor who's got his back. Well, it was Obama, and he was informed regularly, apparently. However, according to Sebelius again, he was not made aware of significant problems until a couple of days after the website had been launched. So the corollary to having, in addition to having a stakeholder, and then having the executive be your stakeholder, is communicate constantly and completely. There's really a stack here. You've got a very, very strong leader. You've got an executive at the highest level possible who's got his back. And then you've got to have a lot of lines of communication functioning up and down, all over. There had been a McKinsey report done in spring of 2013 that was warning of what was happening. These problems were foreseen many moons in advance. However, they were not acted on by the chain of command to the extent one existed. The keep requirements stable, part of this, we went through requirements instability, so the flip side of that is keep the requirements stable. The Supreme Court got involved. Many more states decided to handle things. New requirements dropped on the team. That's all going to lead to the project manager having to make choices. An empowered project manager is able to make solemn decisions, going up to the people who want this project done and telling them point blank, toss features or and keep the date. Which do you want? If you don't toss features, you don't keep the date. What do you want? And that's a cold, hard reality. There have been tales of legendary project managers out there. I'm thinking of one particularly at Rational, who wrote a book on this, the old Rational software, who was famous for always coming in on deadline. And the way he did that was he tossed features. But in the end, he was remembered for always bringing projects in on deadline, not tossing features. Had they done that with HealthCare.gov, had they been able to do that, they would have delivered on time. Had they not been able to, well, they couldn't keep the date, and they should have just owned up to it. Another lesson learned here is that there are off-the-shelf alternatives. If you look around the marketplace, you're going to find, and many of you have probably used, online health insurers who are qualified to serve in many, many states. They've built these systems over quite a number of years already. They're not as complex as the Federal Exchange, but there's a certain amount of off-the-shelf that the feds could have given. And not only that, but there are firms out there, Oracle, Microsoft, and Towers Watson being among them, some of the major ones, who produce insurance exchanges. That's their business. But they weren't asked to provide an off-the-shelf or customize their insurance exchanges for this purpose. This was something that came out very early, and I doggedly looked for the reasons for this and couldn't find anything until Darrell Issa, no friend of Obamacare or Affordable Care Act, but I assume he's lived through a few congressional testimonies on this, and we're going to have to take him at face value here. The healthcare exchange was simply made new for no particular reason, except for lots of people who wanted it. So that's the best answer I've gotten so far. Another lesson in this is don't blame the contractors. None were in charge. 55 were engaged. There was no prime for integration testing. And it's been asked more than once, well, you know, if Facebook can do this and Google can do this, why can't we just hire one of those? The answer to that is those companies are already busy. The number of contractors able to do big work for the government are small, and they're already working for the government. The market is already well developed in terms of contractors who do this sort of thing, and they already all are government contractors. There are none else available. Another thing that would have set people straight from the start is that, of course, we're an estimation company, so and we believe in this. You need to start the project with a realistic estimate, and then you can have a frank discussion before code has been committed. And to our knowledge, that reliable estimate had not been made, so that is certainly another lesson learned. A little update, given we're now in February. I started this update in January. That's the date. The New York Times, a reliable source on what's happening with Affordable Care Act, is showing that everything's moving forward. Things are being forgotten as people register. However, the system itself, which initially had been estimated to be only 30 to 40% complete, is still showing growing pains. These things are, each one of them is being addressed in turn, is my understanding, but there are many, and each of these headlines details a different major problem with the current federal health exchange. So HealthCare.gov is still, under the hood, growing and expanding to its full necessary scope. Is it uniquely a federal problem to have these issues? It turns out that they're very frequent. Here are 8 separate instances, and this is usually in entitlements programs, CHIP, infant, all sorts of, where you're giving people money, basically. The entitlements programs at the state levels have, many of them existed for many years, and they're being slowly redeveloped because of the age of the underlying applications, and also because with the move to the internet and the web, states are finding that it's much more efficient to provide these services online, and so they're redeveloping their systems. There have been at least 8 major disasters that have occurred. We know of many more that don't warrant this board, but these are problems with systems that are, some people think, due to acquisition issues, some people lack of leadership, some people complexity. We found 2 people. There were a lot of commentators on what happened, but 2 of the best, I actually put them up here. One was the former New York City Deputy Mayor, John Martin, who wrote about their experience. They had a huge problem in New York, and they created a corporation with the in-house expertise to manage projects. That's its sole charter. And so his lists were, you need that executive leadership, as we mentioned. You need to bring in stakeholders, not just the big ones, but also the actual people using the system, the bureaucrats, because they'll tell you how it will go wrong. You need a specialized group of people who are very fluent in acquisition management and negotiation, and who are basically the red team for managing contractors. Networked governance is a translation for, you need that level of communication and of constant retrospective and deep views into the project that goes all the way right up to the top. Elevate substance over procedure. We know that large firms often are the only ones who are able to prime on these projects because they have such an administrative overhead, and they aren't necessarily the best choices in many cases. Another lesson is that these government systems, government isn't necessarily bad at doing software. Government's been doing software before anyone else, in fact. They're just difficult systems. The government does more complex systems than other people. And finally, when in doubt, don't do it. Buy it off the shelf, or just don't do it. And one more, John Gilligan, who was formerly CIO of the Air Force. Break larger projects into useful capability. So these are the idea of sprints, really not sprints, but incremental deliveries that are shorter, and so you can bound your risk better that way. And then also, again, the leadership. He goes back to the theme that we've been emphasizing throughout. And he was CIO in many different capacities, so I think John has a very good perspective on this. Well, that's it for my piece, and I would love to turn this over to Dave Herron and hear what he has to say and what DCG's perspective is. Without ado, Dave?
Hey, thanks, Lee. I quite enjoyed that. I hadn't heard all of this before in your first go-round, so quite informative and appreciate it. Anyway, and I'm going to talk to some of the things that you mentioned and some of the solutions that we have found to be satisfactory for our client base, if you will. You can go to the next slide, if you would. So these problems, Lee, that you were talking about, obviously, and you said as much. These really aren't anything new. The inability for a project team to properly plan the project, manage their requirements, scope creep, all of those good things. Ineffective communications, really just generally not managing the project very well. Either not having the wherewithal to do it, not having the proper skill sets, skill levels to do that. I would even venture forth to say in some cases not even caring to do it or not thinking it's necessary. But be that as it may, whenever we are invited into a client site and they demonstrate, some or all of these problems, basically one of the perspectives we take is around their decision-making process. Typically, these types of problems are often resulting from poor decisions being made. And so what we've learned is that proper project or program governance, if you will, is really all about making good decisions. You want to go to the next slide, please? Cool. So, yes, proper governance is critical. And really, when we think about the decision-making process, it's quite elementary. There's three parts to a good decision-making process, and that is knowing what decisions need to be made, who in the organization is responsible and accountable for making those decisions, and then what's the process for how those decisions get made. And, of course, making these so-called right decisions really is all about having the right data available for you at the time that you're going through the decision-making process. And one of the key pieces of data for software development, for sure, is knowing the size of the problem you are trying to solve. So having a proper software sizing mechanism becomes key. And you see here, so sizing is, in fact, a key factor. The proper sizing technique helps to set expectations. How big is this thing that we're talking about? We saw some incredible flows, or not even flows, but diagrams, system diagrams in Lee's talk. How big is that really? Proper sizing technique, I'll hope to make a point about this in the next couple of slides, can add to clarifying the requirements. Lee had a slide there that talked about it's a trade-off. You can toss features or be on time. Well, how do you know what features to toss and what the quote-unquote size is of those features? Size, a proper size metric that also gives you a sense of the overall complexity. Not that bigger is always more complex, but certainly there are certain complexities that come along with increased size. Managing scope, if you can size the scope, one would suggest you might be a little bit better to make some decisions about changes that have to be made in managing that scope. And then to tie in with Galorath and he was talking about estimates, certainly size is a key parameter or key variable into any proper estimating model. So one of the leading industry sizing techniques we use with our clients is something called function point analysis. So if you go to the next slide, please, Lee. So if we look at the opening sentence here on this slide, I've highlighted some key words, if you will. The fact that the function point analysis sizing technique is standardized, what's important about that is that it means it's going to be applied consistently from project to project, throughout the organization, throughout the industry. So there's the ability to do some comparative analytics, comparing one size project to another. Measuring. This is a quantification of size. It's not an opinion-based view of the software problem domain. It's a quantification. It's a specific number, if you will. And what it's measuring, the best part of it all, of this measurement technique, what it's measuring is the functionality being delivered to an end user. So here we're talking about a consistent method used for the quantification of the features and functions that an end user has asked for and is receiving, what's being delivered to that customer or that end user. So you think about that, immediately some benefits come to mind, right? So I've already talked about it being a good measure for comparative-based sizing. I've talked about it as a key input parameter. There's a fair amount of industry benchmark data that's function point-based. So you can set reasonable expectations about, how big something is and how long it might take to produce. And I think what we see more times than not is that function point analysis is positioned to be used in tandem with managing customer expectations. In fact, the function point analysis method talks about some of its sizing measures in terms that the end user can understand. So, Lee, if you want to go to the next slide. So really, and just a quick tutorial, if you will, on function point analysis. Obviously, we can't go into it too deeply, but basically the function point methodology asks us to, when we're sizing a project, an application, or whatever, to look at the size based on the examination of 5 key components. And they are, what's the customer asking in terms of being able to input data into the system? What is the customer asking for relative to getting data out of the system, getting information out of the system? It also asks, the function point methodology asks to identify any unique inquiries where a request is made for information and an immediate response comes back to the customer. The fourth element, if you will, the fourth component, talks about identifying all opportunities to store data. So on a transaction-based system, constantly inputting data throughout the day, well, you want to keep that data. You may need to come back to it at a later date. You may need it for additional processing and whatnot. So we want to capture all the information relating to what the user needs in terms of keeping that data, maintaining that data. And then the fifth element is identifying interfacing to other systems. And so in a big project like HealthCare.gov, it's comprised obviously of a number of different systems, applications, projects. And so you would be measuring this probably at the application level. You would have a lot of different sizes as a result. And you could properly focus in on each and every one of those applications, focus in on their estimates, focus in on any scope changes that are going on, things of that nature, and thereby being able to gain a little bit better control, perhaps tying it back to governance, perhaps being able to make better decisions about what features might stay, what features might go, if we're running into time delays or what have you. So function point analysis, it's often talked about in the sense of it's like how people think about when they build a house. They think about the size of that house in terms of the square footage. and it has some meaning to them to understand that a house is 2,500 square feet or what have you. It's something that is recognizable. It's something that's meaningful. It's something that the contractor building the house bases their estimate on. So function point sizing is like the square footage of software. It's just a number. At the end of the day, after you do the computations and evaluate the weightings of all of these inputs and outputs and everything, it's just a number, but it's a number that can be used for a stronger base of accurately estimating the level of effort required to develop and design, develop, and deploy that software. So that's one thing, Lee, that I wanted to talk to everybody about today, how important sizing is. And again, tying it back, it's an important piece of information in the decision-making process. The other common area that we typically address with troubled projects is getting them better positioned to be able to manage risks, risks associated with a project, and equally important, getting them to be able to become more transparent. And so we engage our clients that are having trouble and whatnot in the practice of Agile development. So if you could go to the next slide. Agile's been around long enough to have most everyone acknowledge that when deployed properly, when the principles of Agile, the 12 principles in the Agile Manifesto, when they're truly realized, that it certainly can become a very effective way to build out a project. It can be a very effective development methodology. And we all know that it talks about, Agile talks about improved communication, talks about better scope management by these shorter delivery cycles, the constant feedback loops, if you will. Talks about them being able to, as a team, be self-managing, self-organizing, and manage their environment. What I think is really a key reason when Agile works and when it works well, one of the key elements that we've seen is that it's followed in a very disciplined fashion, in a very disciplined manner. Lee talked about that the development of the HealthCare.gov was iterative. With incremental deliverables. I don't know what the cycle is, but certainly one of the things that we would look at in that life cycle management was the level of discipline that was executed in terms of following the principles and the practices of whatever life cycle methodology they were deploying. Go to the next slide. So some of the core characteristics of Agile is, we know with Agile the focus is on the customer and understanding what the customer wants. Managing, we keep coming back to that need to better manage the scope of the project. So along with something like a good measurement technique like function point analysis, so that you can improve the effectiveness of understanding the requirements and managing the requirements. There's the frequency of delivery, the frequent delivery cycles, and therefore that feedback loop is shortened, thus avoiding any lengthy delays in the development and delivery process. Next slide, please. So clearly, the benefit of Agile for us and what we talk to our clients about is that it incorporates the voice of the organization. It incorporates the voice of the team, the development team, and, of course, the voice of the customer. And so there is an increase in information being shared, trying to bring this full circle back to government. And that information is what drives effective governance and improved decision-making necessary for keeping these kind of trouble projects out of trouble. So with that, I'd now like to turn this over to Dan Galorath. Dan?
Thank you, David. Next slide, Lee. So we've mentioned estimating a few times here. I thought I should define an estimate. We define an estimate as the most knowledgeable statement you can make at a particular point in time regarding effort, schedule, risk, staffing, and reliability. So an estimate isn't a single point, 3 years and $300 million, but a range. And that range gets more precise as you have more information. Next slide, Lee. One of the problems we've got in dealing with estimating or software development or almost any project activity is human beings are hardwired to be optimists. Click next, Lee. So we're all hardwired to be optimists, and that shows in all kinds of areas. And one of the things we need to do to deal with that optimism is to temper it with an outside view. Past measurement results, traditional forecasting, risk analysis, and statistical parametric methods can help. So I'm not suggesting we should remove optimism, but balance optimism with realism. There's study after study that shows the same thing, that people on their own will assume things will go right. And unfortunately, things don't generally go that right. Next slide, Lee. Here we can see the range of a traditional software project. There is a minimum time to get any software project done. There's not much you can do to get it done any faster, except, as Lee said, descope or do something smarter, do off-the-shelf software or some other technique, some other better technology. Next, Lee. Let's keep going to the next slide. The other thing that's important is looking not just at the development costs, but the total ownership costs. Lee mentioned $300 million of development costs thus far. That's only the tip of the iceberg. This system will cost many times that, and I'll talk about it in a minute, over its life cycle. Now, the truth is you got to do it, so that's okay. But knowing the costs can be extremely valuable. In some cases, there wouldn't be a proper return on investment, and a project should be deferred or not done at all. In this case, of course, they had to do it. Next slide. Here we can see a little pie chart here. The software development in the scheme of things is that little tiny piece, about 20-25% of total ownership costs. Software maintenance, the red piece, is about 75% of the software costs. But IT infrastructure and IT services drive it to about 60% overall. If you do the arithmetic, software development is about 6 to 10% of total ownership costs, but it's about substantially more of the risk. So in this case, a $300 million development is probably over $3 billion of total ownership costs. Again, good to know this project had to be done. Perhaps there was a way to reduce it, as Lee said, but these things are expensive, and it's going to be expensive for a long time. Next slide. Lee touched on this, the iron triangle for software, really any project. Quality being in the middle, you've got the scope, how much stuff you have to do, the resources to do it, and the schedule. If you vary one of these without any other compensation, then quality suffers. Next, Lee. Bottom line is you can have it faster, you can have it cheaper, you can have it gooder or better, and you need to pick two. What that points to, again, is that it's ideal to look at and understand realistic schedules and then descope or plan incremental deliveries or whatever based on what you can really do. Again, it's hard. Humans are optimistic, hoping everything goes right, and it never does. Next slide, Lee. Just go through this slide onto the next one, Lee. This slide just showing that there's an ideal way to staff. Keep going. Go through the whole slide, Lee. And if you don't staff ideally, you end up wasting effort up front and with additional schedule. Keep going, Lee. Next. Now, one of the problems, and the diagram in the background is that diagram that Lee showed. It's a pretty scary system, how much complexity was involved here. And one of the issues is, remember, there were 55 contractors. I don't know how many, but probably thousands of people. And one of the issues is the more people, the more contractors that are involved, the more issues there are with communications and communications entropy. So one of the problems here was was more contractors, more entropy. Now, I'm not saying there shouldn't have been so many contractors, but as Lee said, having somebody in charge could have really helped. Next. One of the things also is when do you ship? Again, they had a fixed date here with HealthCare.gov. They weren't allowed to defer functionality. Some got deferred apparently by default because they just couldn't make it work. Next slide, Lee. Here we can see a little output of defects at delivery date. Here we can see at month 65, this particular system was when it's recommended to be shipped. It still had, I'm sorry, on 3209, it still has 65 defects. If you ship it early, you can see nextly. There's where we should ship. If you ship it early, you can end up with 400% more defects than recommended. That means lots of things. In some cases, it means the system will die and never be used. In other cases, it'll mean problems like HealthCare.gov. Nextly. And on the other hand, if someone says, well, let's just test it ad infinitum, you can't really ever get all the bugs out of the software. So there's a point where you just got to ship and then fix and maintenance. Here we can see the defect insertion and removal rates and how those can help us to get a visibility into software. The example here, we see the red line is on the chart on the right, is the estimated number of defects inserted into the software over time. And the green line is the actual number of defects inserted. So here we thought we increase, we find X defects, we found Y, and Y is bigger than X, so that could be good or bad depending on your system. You found more and it's good maybe. But if you look at the other line, the blue line shows at what rate they should be fixed, and that purplish line shows actual fix rate. In this case, we found more, we fixed less, this project's in big trouble. Using that as a health and status for any software project can be a major improvement. Next. Now, the other thing, even for the areas that were packaged, like Lee said, you use off-the-shelf software, still 1/3 of the budget, a huge amount of money, needs to go to testing. Just because something is off-the-shelf doesn't mean it's going to support the organization or the mission. So testing needs to be a huge part of a system, even for off-the-shelf software. Next. One of the things we always recommend is a process for actually estimating. And this is a 10-step process for doing it. Basically talks about figuring out why you're estimating, figure out what you're estimating, doing it, factoring in risk, and then having a plan that tracks to the estimate. Next slide, Lee. David talked about functional size. This chart shows typical growth in size. When the requirements are first talked about and thought about, things always grow for a number of reasons. Here we can see in the left there, it's almost 2-to-1, the amount of growth over time, and typically it's about 150%-ish growth. So not planning for growth in the requirements is a mistake. Now, if you're agile and you can defer them, great, or if you've got another way to defer requirements, that's great. In many cases, such as this one, they had to do all this work, and the additional growth in functionality didn't give them any relief in schedule, so this was a disaster waiting to happen. Next. Some of the other things people do, again, we're all optimists, optimistic assumptions on reuse. Even a system that has to be, that's completely off the shelf needs to be retested. And when you start changing it to work with anything, for example, this might be one of the legacy systems that had to be changed to integrate with HealthCare.gov, things skyrocket. So it's important to look at how much will have to be redesigned, re-implemented, and retested. When people say software is off the shelf, I always like to ask, well, great, I suppose it was on your aircraft, and they didn't test it again because it had worked before. Would you get on the airplane? And the answer is probably no. Next. A million other things to be looked at as well. For example, IT services. If you look at some of the problems when they first launched the system, it just didn't work. And IT services should consider the skill level of the people involved and have a service level agreement that gets things fixed very quickly. If you look at some of the analysis of HealthCare.gov when it was first shipped, people looked at the JavaScript that was being sent to the browsers, and they found, I think it was 5 different tracking tools. They found, I think it was 5 or 6 times as much JavaScript as would be needed in a production system. Well, what most of us do in systems is we get it working, then we get it working efficiently. This clearly, they didn't have time to get it working efficiently, and that was part of the issue. Those things should be considered and modeled, though. Next. Testing in production environment. Again, to test the production environment to avoid surprises. Again, they didn't have the bandwidth, I guess, in the HealthCare.gov, just didn't have the time, but some kind of test should be done with hundreds or thousands of users before it was put in the field, and it was found that it just couldn't handle that. You can see the cost and is more, but unfortunately, those are things that have to be done to deliver a complete system. Next, Lee. Here we had, again, a system with users that were kind of one-time users that had any level of skill level. Some probably couldn't even hardly type, and others are computer gurus. Having a support capability in place is important to walk people through the systems, and we all heard the stories early on about how this didn't work well. Next. Security. Some of the reports showed the software and system wasn't secure. There's lots of ways to put security into systems, hardware ways, software ways. If you look at the graph here on the upper right, that shows the cost increases in software development to build security into software. As you can see, it can be up to 400% of a non-secure system, depending on how secure this must be. And this system has lots of personal information, wonderful things for identity theft, I suppose. So this needed to be secure. Next. Risk analysis. Every system needs risk analysis, but both schedule and cost risk should be looked at. If you use a most likely or 50% probability, that says there's a significant probability that things are going to exceed. That might be okay, but it's usually better to use a higher probability so that we understand better what will happen if things go wrong. Next slide, Lee. Here's an example, and these are just durations where people estimated durations, and you can see there are 30 days, there are 50 days, etc. And just by using a single point estimate, just doing the estimate, remember, people are optimistic. You can help it a little bit by asking for 3 points. Next slide, Lee. Here we see the same estimate, except we've asked them for the best case, likely case, and worst case. When we drew out the worst cases, notice on the step 1 there, even though the expected was 30, the best case wasn't much more than that, and the worst case was over twice as much. This is not unusual at all. We find when we ask people for the best case after they've given us an expected, it's almost always, if they're not familiar with range estimating, it's almost always they're estimating the best cases. Next line. Here we can see a risk analysis. This is a Monte Carlo analysis done with this information. Remember, our original estimate was 500 days. You look at that, there's just about a 0% probability of actually getting it done in 500 days once we understood the ranges and the uncertainty. The 50% or most likely is 731 days. It still says that there's a substantial probability of exceeding. And a 90% confidence that the system won't be exceeded is 817 days. Remember, our original estimate was 500 days. So applying risk analysis to every project, I believe, is critical. Next, Lee. So the bottom line here is what we tried to cover was that IT systems are hard, and HealthCare.gov was in a difficult environment. They were in a kind of a no-win situation. They had requirements that were completely volatile. They had no control over that volatility. They had a system of complexity that's far more complexity than most systems that they had to deal with. Now, of course, they can do it. It's just there's time and there's money involved. They had to integrate with all kinds of systems. Many systems, and systems integrations are vastly expensive and difficult to test. They had to work with legacy systems that are stovepiped, and much of it was probably old COBOL from decades before. They had a forced deadline that was just not achievable, and they couldn't defer functionality. They couldn't plan for deferred functionality. What got deferred ended up being things they just couldn't get done. Lessons learned, again, were maintain leadership. Make sure somebody's in charge, and make sure the executives understand that. And that the person's in charge, or the group that's in charge, is got the power to make things happen. Again, I'm not saying anybody could have said, "We'll just delay HealthCare.gov for a year because the IT isn't done," but I suspect somebody could have come up with a subset of functionality. Communicate constantly. We saw there's entropy, there's cost of communication, but it's even more cost of not communicating. Remember the iron triangle rules. Quality is going to go down. You need to keep features stable or defer features if you want to make a date. Include risk in your plans and practice extensive risk management, including a risk register. Test the entire system from end to end and do it often. Don't just throw it out there and hope it works. Again, these people didn't do it intentionally. They didn't have time. And don't just blame the developers. This was a system. This was a death march system, and the developers actually did pretty admirably considering the issues. Use commercial off-the-shelf software when it's viable, but it's also not a panacea. So the real bottom line is estimation, planning, and control can help, but mandate the possible, not the impossible.